Myśliński, and I'm here to talk to you about how to build production-ready software with LLMs. So a bit about my background. I've been a software engineer for over 10 years now, and I've been in the MLOps space for the past 5 or so. I've previously been an engineering lead at Algorithmia and later DataRobot. For the past year and a half, I decided to venture into the startup world by starting my own startup, ML Native, which has later transitioned into what is currently CV2Blind. And at CV2Blind, we help companies to convert CVs into sales-ready profiles we call blinds. And yeah, we also utilize LLMs to get that done. Based on that experience, I'd like to share some of my findings with you today. So I will largely be focusing on that topic in my presentation. What's the agenda for today? We're going to talk about how we can use LLMs effectively, the typical problems we might encounter and how to solve those. But we're not going to dive very deep into the details about how they're built, how LLMs work internally, the differences between different architectures and so on. This is totally not my expertise, so perhaps some of you might also have more to share on this topic, but today we will be treating LLMs as just a component that we're going to be using in our software to build something bigger. Right, so I'm going to assume that everyone here has heard about ChatGPT, right? It's been 2 years since the AI mania has exploded, and yeah, even just by looking at NVIDIA's stock this year, we can definitely see that the mania is still in full motion and there's a lot of hype in the space. So every single big tech company out there has got their own LLM, or they're either working on some product that is utilizing that. And we know that you can build some great stuff with it, right? We've all, I think, seen and used products that make great use of LLMs. I think the most known one that most of you will know is GitHub Copilot, which pretty much most programmers have heard of by now. If you haven't, I totally recommend that. It can definitely change your workflow quite a lot. So I think this is a great example of how you can use LLMs effectively to really deliver business value, right? It's not a gimmick. You can definitely tell that this definitely boosts productivity, even though there are some concerns about GitHub Copilot itself and how whether they have the rights to train based on all of the public code and so on. But I think it's undeniable that the product itself is great. But there's also different examples where companies might, rush it a bit to use LLMs in their software. So here we have a great example of DPD, which has decided it's going to be a great idea to expose probably ChatGPT directly in their chat application, directly to customers. And yeah, as you can see, in most cases, it's totally possible to just override the prompts and get it to do whatever you want. So yeah, this is not a very good PR for a company when your own chatbot is saying you're the worst company in the world. So there's definitely learnings here. This happened no more than 2 months ago, I think. And I think we can find a lot of more examples similar to this one online, where companies, try to get something done, but then it has backfired spectacularly. So we're going to try to understand how we can avoid that fate, and how do we actually build a system with LLMs. At the top you can see how we're going to really think about LLMs today. Namely, we don't really care how they work internally, we just treat it as a magic black box, right? So there's an input, there's an output, and we treat it like an external dependency of our system. So what you can see here is a very basic example from OpenAI's website. It's essentially a Hello World application that uses ChatGPT. And in each and every case, you have to specify at least 2 messages, one of these being a system message, which basically tells the system how to behave, and then a user message, which essentially contains the actual instructions of what you want to achieve with the LLM. And as you start out playing around with that, this is This is what the most basic example looks like. But if you try to utilize more calls or in a bigger application, you very soon start noticing that there are some issues with this approach and the way LLMs are structured. So the biggest limitation of those is that they are inherently text-based, whereas all of programming is based on data structures, and text isn't really a great data structure to work with. So what we always want to do is convert it into some sort of format that we can work with programmatically when we're making any kind of LLM calls. And there's already plenty of solutions out there on the market. However, yeah, converting stuff to JSON is still quite a complex problem when working with ChatGPT or any other LLM for the time being. So we can do a lot of fun stuff like specifying a Pydantic model. What you can see on the screenshot is a class which has some specifications, namely we have a table name and a table summary. And we pass this table definition to an LLM call so that the response from the LLM itself will try to fit this data structure, right? And then on the code side, we simply get back a class which probably will, more on that later, contain the information as described here. But even if we're using some sort of dedicated tool to get this data out, there's a problem that we never have any guarantees that it's going to work. So even if there's third-party tooling that allows you to get that data out, they always mention that you should still put within your prompts code that's going to say, hey, give me JSON, or what the response structure should be. So for now, we don't have silver bullets. There's also function calling, which allows you to call functions that you have defined within your code base as part of an LLM invocation. But that still, has the same limitations. So we still need to put that information how we want our data back. So for the time being, I've listed on the left-hand side the already existing libraries that you can use for this purpose. However, based on my experience, it's usually good enough to just specify the response structure that you want within the prompt. What you can see here on the right-hand side is a very basic example with a slightly complex data structure, I would say, where we have, we want to get, we ask ChatGPT to provide us with 10 spell names and their effects. And the data structure involves an object with a single field, with a nested array, I think there's a total of 3 levels of nesting. And this particular use case, where we have more than 1 level of nesting, is actually where these libraries tend to struggle. Whereas if we specify the format ourselves, that usually, I've just found this to work a bit better than if you're using dedicated tooling for that. Okay. Another problem you might encounter is the actual size of the data that you're trying to work with. So most LLMs have got the size of a context window that they can work with, which usually ranges from 8 to 32,000 tokens, whereas a token is somewhat equivalent to a word. So we don't need to get very into the specifics here, but that's a fairly small window size in terms of the entire data structure that you might require to send to actually get an answer. So we have some models which actually came out quite recently and support massive context windows up to 200,000 tokens. However, you could use those. Let's say you have a massive document and you want to do some basic question answering upon that. That would work. However, for one, that's going to be very costly. So even if you look at the latest slightly reduced GPT-4 pricing, if you were to expand the entire context window for a single request, you would be paying roughly $2 to $3, give or take, for a single request. Now, I'm not saying you can't do that, but usually if you're trying to build a product which is going to be an improvement to any existing business processes, right? Like, you can't make it 1,000 or 1,000,000 times more expensive than what's already out there. Now, if this use case is super demanding, that might work, but usually, as with any other type of software product that's being built, you want to strive to get this to run as cheap as possible. So, and a very straightforward way of getting that done is simply using smaller models. So we already have a ton of models on the market, closed source ones, open source ones. But for most problems, usually you don't need state of the art. You don't need ChatGPT 4, you don't need Claude, whatever the name is, the most advanced models from Anthropic and so on. Usually you can get the job done with just the simpler models, which cost usually from 100 times to 1,000 times less than the state of the art. So that's one reason you can approach that. And the second thing that we can try doing is just reducing the input and output size to answer, to solve whatever problem we're trying to solve, right? So one thing I also wanted to mention is self-hosting as a way of addressing the cost issue. So I don't think it's really viable yet. Of course, there's plenty of great open source models, but then if we try hosting those and using them in production systems, we're going to run into all the classical MLOps problems, right? So we got to make sure that the latency is okay. We got to provision enough GPUs. So unless you're a medium-sized organization and you want to dedicate resources to it, that's totally fine. But I just don't think it's worth it for a majority of cases since it's not that expensive. So unless you have a good reason to do so, I just stay away from that. And then finally, as it comes to reducing the context size, there is RAG, which stands for Retrieval Augmented Generation, which is all the craze now. So if you've heard about LLMs, there's a high chance you've also heard about RAG. So this is a very advanced topic, but what it consists of at the basic level is if you have, like, let's say 100 documents and you know that the information you want to provide for the query is somewhere in there, you basically build a vector space representation of all these documents. So you create embeddings, and then you put all of these embeddings inside a database called an index, and using like more classical ML approach, usually that would be top-tier retrieval. You try to find the most relevant data for the query. So there's a lot of different stuff you can do to retrieve the data, but yeah, this is a very deep topic in terms of it all deals with the problem of retrieving the right data for your query. So it's a great technique. However, like I mentioned, it can get quite complex. You can build very cool stuff like query planners. So you can combine different tools which fetch data from different sources, different data structures. One can work on pandas data frames, another can work on SQL. A third one could be just fetching stuff straight from documents. And you could combine all of these sources in a single query and tell the LLM to just figure out which one is going to be the best source to answer. Now, and although this does work, and it's very impressive, and it's also quite cool on the technical level, you can go quite deep into this. There's great tooling out there which allows you to build applications with this toolset already. So the two icons at the top, that's Llama Index and LangChain, two leading open source libraries for building software, especially with RAG that we were mentioning here. But I also think that this is a double-edged sword, and I'm not sure if it's worth the effort in a lot of cases. So one of the biggest problems with LLMs is non-determinism. So they're inherently non-deterministic. And as programmers, we absolutely hate non-determinism, right? We want to know that when you run your code, it's always going to run exactly the same. And there's zero guarantees with LLMs. So there's a parameter called temperature, which you can usually specify with each and every query. And that parameter ranges from 0 to 1. However, even if you specify it as 0, that only means it's the least likely to change the responses with each output. It doesn't guarantee consistency between each and every request. So yeah, that's quite a big problem. So we always have to assume that our program can break and can go wrong, right? That means that every time we're using LLMs, we need to set up proper validation boundaries. to make sure that they will be working correctly. Another problem, which you also might have heard of, is hallucinations. So LLMs have a tendency to make up data out of thin air, since they're inherently systems about probability. They really don't, they have a hard time sticking to the truth and actually using source material. So if you're trying to do anything that has to do with more fragile use cases or data, so what I mean by that is, for example, medical advice, and anything healthcare related, really. Legal advice, there's a lot of people building like legal assistants or, tools that can help you write any kind of legal paper, auto doctors, whatever. This is very, very dangerous, right? Because there is no way to guarantee that there's any kind of source for what the LLM is provided. So yeah, there's a lot of problems with that. And then there's the more classical problems that come from traditional software. When we have a third-party dependency, these problems may always occur. So, our request might fail. That means we have to have red tree in place. We need to make sure that the response is valid. I've already mentioned the formatting of the data and the fact that it can break at any time. And there's also the issue of latency, which can also vary greatly, even with quite popular third-party services. So for ChatGPT, one day you might get the 5-second response time, and then at a different hour, a 15-second one. So this can impact production systems quite heavily. And then what we have on the right-hand side, the graph of uncertainty. So what I mean by that is that if you're using the response of an LLM as an input to another LLM, you're effectively exponentially increasing the complexity of the unknowns that might occur in your application. So this is usually something that you want to avoid. And that's why I tend to recommend something I'd call a hybrid approach, which I think can be more easily summarized as just trying to contain the usage of LLMs and trying to even avoid them as much as you can, right? Because as cool as they are, we should really, in the first place, ask ourselves, why are we trying to use this? And what is the business problem that we're trying to solve here? So if there is a way of decently enough solving a business case without using LLMs or somehow limiting their usage, I think that's a much more sane approach than relying totally on ChatGPT or any other tool. So now I want to give you a quick example of what I mean by that. So within CV2Blind, we have a very simple feature. Once we extract all the data from a technical CV, we, as tech people, usually put all kinds of technologies that we know in our CVs, right? And these can take very different forms. So what you see here on the right-hand side is something we have parsed out of somebody's CV, and you can see that the format varies greatly. And frankly, the set of keywords is almost unbound by the fact that there is no single format that we know people can use, right? Someone might put JavaScript by itself, others might put a list of libraries. And this might also exist as a keyword. So this is one of these problems where LLMs might actually be a good fit to solve. So namely to tell us, okay, what do you think this keyword, what's the category, right? Is it the programming language, is it the database? And right now, let's try to quickly think how we can solve this problem either initially maybe just using LLMs. So what we could do is just every time we extract these keywords, we just send all of this data to ChatGPT and ask it to query a number of online data sources, right? So let's say we specify 2 or 3 databases where we wanted to look for these specific keywords and then try and match those. And this probably would work, but then I really wanted to simplify this, since that's a lot of network calls to be making for each and every CV. So we decided to just add some optimizations. And what I mean by that is we still send a query to ChatGPT to ask for those keywords, but as soon as we get a response back, we cache all of the responses, and we also allow our users to do any manual modifications, right? So if anything is incorrect, we simply allow our users to drag and drop the keywords, and then we store all of these modifications and responses from ChatGPT so that the next time similar keywords occur, we don't have to query as many with as many keywords. Plus, over time, our data set gets better and better, so there's less stuff we need to query, and effectively over time, our accuracy increases. So, it's a very simple example, but even if you try thinking about how you can simplify the problem, it can be quite useful and help you reduce the dependency on external systems. Right. So as you've seen in the Hello World example, prompts are, after all, text strings, and usually everyone starts out by simply hard coding their prompts, myself included, and we just store those into Git. However, you quite quickly discover that Git is great, but just like with traditional ML models, you want to version your prompts separately from your application, and they also undergo the similar life cycle as ML models do. That means we should version them, we should track their usage, we want to compare them side by side, and that's where third-party tooling comes in. So what I've listed here are the two ones that I've used, namely LangFuse and PromptLayer. Both are quite great. So they definitely address some of the problems that might occur. Cost is also quite a big topic. So you definitely want to know if you allow your users to make these calls. These costs can, as I mentioned, skyrocket quite fast. So tracking those is also quite important. Right, and then one more feature, which I think LangFuse for sure offers, not sure about PromptLayer, is evaluation. So let's say we're building a system which is doing generative AI. So we're generating some content, and yeah, you might want to be able to track how well your current prompts are doing and whether the changes you're introducing to your prompts have a negative or positive effect on your software. And there's few approaches you can take by now. So this is what LangFuse is offering. You can either just manually click in the UI and say, okay, this is great. Give it a ranking of 1 to 5, ask your users. You can do that programmatically, but the most interesting one here is definitely using LLMs to evaluate LLM calls. So I haven't really used that one before, but for some problems, it's more complex and labor intensive than the other. So I haven't frankly used any of these yet, but since this is quite a complex topic, at least for my particular use case, but going forward, I would very much love to have this in place, since right now I have zero guarantees whether the changes I'm doing to my prompts have a positive or negative effect on the quality of my software. So having that information is definitely crucial in the long term, especially as your project matures. So I would definitely keep this in mind. And there's one more problem that I wanted to mention today. So that's regulations. So as most of you know, we are in the European Union, and there's a very cool new regulation called the EU AI Act, which has been just approved. And so for now, it is partially in motion. What this means that you can see there's 4 categories here, ranked from the most dangerous to least dangerous in terms of how they judge the AI systems. So the systems in the top category, that's number 4, this is already in place and motion, so they're already fully in legal, right? So let's have a look at what actually falls into the 4th category. This would be any kind of system which uses AI for biometric identification, facial recognition, and so on. Anything that, frankly, if you think about, Orwellian society or in 1984 or modern day China. So this is something that along those lines. So yeah, and these are fully outlawed, so I wouldn't even try building those right now. Next up, we have the systems that are judged as high risk. This is anything that has to do with management of critical infrastructure, and it's also the examples I gave you earlier. So that's namely anything that gives legal advice, anything related to medical data. So while these are not illegal, it's very difficult to get these systems online. And the reason for that is your solution will have to be assessed before being put on the market and also throughout its life cycles. And people will have the right to complain about your system to designated national authorities. So good luck with building that. Then there's systems with limited risk. So one very common example is chatbots. And then, frankly, any system which does stuff like generative AI. So one big impact for this category is that I don't think this is already in place, but it definitely will be in some time. Namely, any AI-generated content should be labeled as such, right? So this is actually a fairly good change. So I think we can all agree that, you know, deepfakes is something that probably shouldn't be legal. Yeah, but it also has some serious implications for us developers and for all the systems in this category. Yeah, you have to disclose that the content was generated by AI. And then there's two more problems for people that are actually building the models. So you have to make sure that the model cannot generate illegal content. I have no idea how to even think about that problem. And then, yeah, you have to publish summaries of copyrighted data used for training. So good luck with that as well. And there's also the fourth category where, you know, there's no strings attached. You can just build and use that software. Here you can see listed that's AI-enabled video games or spam filters. So doesn't sound like much. Right, so as you can see, there's a lot of fun coming with regulations. Yeah, and that's pretty much most of what I wanted to talk about to you today. Here's a quick recap of most of the stuff I mentioned. So on the top, you can see the problems that you might encounter when building LLMs. And then, yeah, what I recommend to do about them, right? So try to stick to smaller models. Definitely leverage the tooling that's already out there so you don't have to reinvent the wheel and stick to what has already been developed. Don't really go in on the LLM hype. So they're perfectly fine and absolutely great, but just try to think of the business case you're trying to solve first. Always isolate them so you don't end up like DPD. And then, yeah, please think about your regulations before you go online. And then some bonuses, since I didn't really know where to put this. So just a few small tips. You can, if you want to use ChatGPT, you can also use ChatGPT, which is hosted by Azure. So the cost is usually the same, but it's much faster and more reliable. So we found the latency difference to be like 2-3x. And also, if you sign up for Microsoft for the startups, you can just use it for free. So for like 12 months. So that's a no-brainer, really. In terms of technologies that you can use for working with LLMs, obviously Python is the king. A lot of libraries nowadays are building TypeScript interfaces, and as the case. So if you know that you don't have any like big requirements in terms of data manipulation, I guess that's totally fine. But you know, just to be on the safe side, I'd still just go with Python. And then finally, one more library that I didn't know where to put. That's LLM. So this is a pretty cool library that allows you to gives you a uniform API for all the different LLMs. So you can just easily swap between 50 different LLM providers with just swapping the API keys underneath, and the API stays the same. So if you want to do some experimentation, compare how your prompts work or your code works with different providers, this is a great util. So I think this is all I had for today. So if you have any questions, yeah, super happy to take any now.
So if you have any question, please raise a hand and I will come up with a microphone.
Hi, thanks for the presentation. I have a question related to LangFuse. So you said that you can, for example, version prompts within the LangFuse. So does that mean that whenever you have an application that uses the prompt, it first goes to the LangFuse, which will become like a central place in your system, which versions the model, and then the application which uses the prompt also reports some metrics or the fact that it uses it this many times and so on?
Essentially, yes. So one aspect that you mentioned that I'm not a big fan of is that if you use it for storing the prompts, in theory, you have to make a network call every time you want to run a prompt, right? So that's quite inefficient. You can obviously just cache that locally. But yeah, that's what it does for the most part. So one is storing the prompts, and then as you make the call, our libraries like either Light LLM or you can just directly link that. When you make the call, you can say, hey, I've used this prompt, so please just log the responses and the execution times and everything that has to do with it with this specific invocation. And yeah, this works quite well. Unfortunately, we're not on my machine, but yeah, if you even check out the demo, you can see that it's quite useful. So from my perspective, right, as I'm using LangFuse within CV2 Blind, I can see that a single user has expended this many credits, right? So we have different levels of nesting and grouping, either by prompt or specifying metadata, which allows me to track, okay, how much is this particular user costing me, right? So very, very useful, and yeah, much better than trying to build this yourselves, counting the tokens and so on. So highly recommend.
I can do it without the mic. I think that'll be okay. Okay, so sorry for your ears in the front. So basically, my question is about validation. So versioning is very good, but with proprietary models like OpenAI things, you can have lowering like precision or lowering quality of the output that you have. So do you think what is the best way of actually checking that? Unit tests or some like manual annotation, some ML stuff like precision? What do you think is cool, or maybe all three of them?
So when you're saying validation, you mean the responses just, right? Whether the response is correct. I wish I had a good answer. So for instance, like as I mentioned, there's a problem with JSON, and frankly, what I found to work fairly well is that, okay, if I get an invalid JSON, like I could just try to come up with an approach to discover where the error is. No, I just take the response, put it in another query, and send it to ChatGPT and to tell me, hey, this is an invalid JSON, can you please fix it? Like, gets the job done. But frankly, there's not a lot of great solutions for it out there. There's these libraries which I mentioned, but yeah, as you use more complex data sets, as I mentioned, they don't work that great. And so I wish I had a good solution for that. So yeah, if you come up with something, please let me know.
I guess you can do that without the mic.
I want to ask about this smaller LLM because I kind of stopped with Llama 2, the open source. Really, they get that much better that you can solve those tasks with 7 billion parameters. Like, for example, you provided this task with this tax. How big model you use for it?
I think the majority of our application right now runs on ChatGPT 3.5. I did run some experimentation with open source models, even the ones which are state of the art, at least by the benchmarks. But I've only used like the Llama 7B model as kind of a co-pilot alternative locally. Honestly, didn't find it to be that good. So probably, I guess people building those are also tuning them for the specific tasks which are there in the benchmarks. So yeah, I'd say they're capable, but frankly, I haven't used them enough. And also one more thing which I haven't mentioned that comes to model interoperability. So by now, our prompts at CV2 Blind are quite complex. So, they can be like 5 to 6 sentences of system message, right? To tell the system how it's supposed to extract the data. And then as I integrated Light LLM and tried using the same prompts across different providers, even at models which are also state-of-the-art, quote unquote, I found that they just completely stopped working, right? That they would have to be re-engineered from scratch. Like the response format that I showed, that wasn't respected in half the cases. So yeah, there's still probably a lot of work to be done here in terms of migrating. So once you choose a model, it's probably best to stick with that model, or at least the family, so that you know what you're dealing with.
I have a question regarding regulations. And
Yeah.
who is evaluating the risk?
I have no idea. I mean, I know this came into place, so you know, this is European level regulations. There will probably be creating all kinds of agencies, and by the time this trickles down to a local level, hard to tell. So as long as you're, you know, just a small startup working on your own problems, I guess you're totally fine. But yeah, as your exposure goes up, your risk also does so as well. And yeah, and also companies, which, you know, if you're building B2B software, companies tend to be very obsessed about privacy and, you know, whether you're complying with all the regulations. So yeah, I wish I had the answer to that, but you know, this is just something to keep on your mind, because frankly, I don't know who's going to be watching that. It sounds like too complex to really be practical, given all these regulations. But yeah, time will tell how this will pan out. So this was just recently written into law, and yeah, hopefully we don't end up with a situation like with the cookie banners, right? So it was supposed to make our life easier, but then everyone hates it, and now we gotta install add-ons so that we don't have to click a banner on every single website. So we'll see how this turns out.
Next, one more question. What was your biggest challenge with using the LLMs? Was it the cost? Was it the latency? Was it like, what was it? The regulations?
Really, it's the fact that so especially in my particular case, since we are dealing with parsing CV data, right? There is no limit to how the data might look on the input. And now writing a single prompt, at least for just a subset of the problem, which is going to work in every single case, you know, this is very specific to my solution. So, but yeah, hopefully you can see the complexity here. Like if you don't know what the input data is going to look like and you still have to make it work, that's quite a challenging solution. But frankly, our customers so far are quite happy with what we have. So yeah, I guess we managed to deliver. So super happy with that. All right, if there's no more questions, then yeah, thank you very much.
Thanks, Łukasz. Great presentation, and give us a sec to change notebook.
Mogę jeszcze na chwilę?
Oh, yeah, sure.
Yeah, sorry, I forgot I had one more slide. So, you know, just for completeness. So yeah, that's thank you slide. Here's my LinkedIn, my startup, and my links in case anyone is interested. Yeah, feel free to reach out on LinkedIn, and yeah, that's all I had to add. Thank you very much.